Hello. So I'm recording a new video, mostly because this is a topic that I haven't covered in previous years, and I think is a really important one to cover because it's sort of expected that students will implicitly learn how do you test and debug. And I don't think that that's great. I think it's actually a better idea for us to really explicitly go over, what are the kinds of things that you should be looking for in ways that you should be approaching problems when you are coding and something goes wrong. It's something that happens all the time, whether it's students, whether it's real programmers. Always there's going to be some piece of code that doesn't do what it's supposed to do, and not only do you want to figure out why that's happening, but also how to fix it. And so we're going to talk a lot about both of these things today as we do some examples of strategies that will help you to figure out what to do when your code's not working. So the simplest strategy is code tracing. You look at code and you try to figure out why it's not working, but just kind of thinking in your head, what's happening at each line? What are all the values, for example, of variables? What operations are being run based on those values? And without actually running the code, you can sometimes figure out what's wrong with it just from that. So, for example, here, there's supposed to be a bug. We get two random numbers, one from 0 to 4, another from 5 to 9, and some stuff happens. So with tracing, what we do is we go line by line, and we say, okay, what's happening in order, and see if it makes sense. Okay, the first, number 1 is a random number from 0 to 4. That makes sense. Modulus 5 means that it's going to figure out the remainder after dividing by 5, and the remainders can only be 0, 1, 2, 3, or 4. So that makes sense. Another one from 5 to 9. Well, we had 0 to 4 was this, and then we're adding 5 to that. Yeah, that makes sense. We had 5 to this, we get 5. We had 5 to 4, we get 9. It's the same range. So our numbers seem to be working out okay. We have a variable called sum. That's the sum of two numbers. That makes sense. We have a variable called difference, which is the difference of two numbers. That also makes sense. The sum, so here's two print statements. This one's one statement, this one's another statement. Maybe I'll shrink the font here to make it a little easier to read. I guess you can't really make it any easier to read. It's going to be on two lines anyway. That's all right. So first one, printf. The sum of some number and some number is some number. So the sum of number 1 and number 2 is the thing we calculated before. That makes sense. Some number is something more than another one. So number 1 is diff more than num2. Does that make sense? Well, we know number 1 is smaller, so immediately actually something must be wrong here, right? Number 1 is between 0 to 4. Number 2 is between 0 to 9. 5 to 9. Which means that number 1 can't be more than number 2. That doesn't make any sense. And then we can go and figure out, okay, well, why is that happening? Well, it's because when we calculate the difference, we subtracted 5 to 9 from 0 to 4, but that's not what we should be doing. What we actually should be doing is the other way around. Otherwise, the difference is going to be a negative number, which is not what we want. So actually, there are two bugs. One of them is that the difference here is calculated incorrectly. It should be number 2 minus number 1 because number 2 is bigger. Secondly, the first number is simply not more than the second number. The second number should be better. So this one should be switched to number 2. This should be switched to number 1. Okay. Now, let's take a look at our next exercise. So here we have test cases. Someone's going to give you a function called square root that calculates and returns the square root of number. Write test cases to verify it's correct. Okay, so let's do that. I don't have my environment open. Why did I not do that? There we go. Okay. So we'll put this under public videos. This is week 5. We got some more exercises coming up, but let's take a look at exercise 2. Exercise 2. Okay. Zoom right in there. Okay. Someone's going to give me a function called square root that calculates and returns the square root of a number. Write test cases to verify it's correct. So for our own argument, we're going to write a function called square root. We won't make it work right away, but what I want to do is sort of illustrate how you want to have a comprehensive set of test cases to make sure that it will actually even if someone puts in inputs that aren't expected, it's still going to behave as you want it to. So let's, now we probably want this to be a double because again, we might be putting in integers. But actually no, let's leave it for now. We're just going to say someone didn't really think too much about it. They make a function called void square root, and it returns 0. Oh, I guess it won't return anything, right? It's void. Okay, so here's my void square root function. It's completely incorrect, as you can see. So the first thing I want to do is write a test case that verifies the code is correct. Okay, well, if my code is correct, then I guess there's a few different ways to do this. I think Jupyter is not going to support all of them, unfortunately, so we're just going to stick with some if statements, but there are other ways to make these tests as well. So we're going to do an if statement. So if square root of, let's say, 4 is 2, that makes sense, print, okay. Or actually, we'll write a little more verbose of a message. Square root 4 equals 2, okay. Otherwise, we're going to print an error. So we'll do something similar. Then we'll just say this. So now if I do this, I get an error right away. So this is very good, which means I already know that there is a problem here. So one test case, I've already figured out that there's a bug. The bug, of course, is that the function is completely wrong. So the first thing that I realized is, okay, the square root function literally doesn't show up. So obviously there's a problem in that, and the reason it doesn't show up is because the computer is looking for a function called square root that I can give a number to, and right now it does not have such a thing. So we need to actually give it one. So let's say int square root, which takes the integer number, and we'll say it returns the number divided by 2. I think we can agree this is wrong. Half of a number is not the square root of that number. However, when I run this, it seems to think we're okay. So clearly what we have here is an insufficient test suite. We've made one test. It made sure that we at least our square root function returns something, because if our square root function didn't return anything, clearly it doesn't function at all. But it seems to think that square root of 4 is 2. Yep, perfect. Okay. Even though we can look ourselves and see this doesn't quite work. So we're going to need another test case. So let's do another one. And this time, okay, well, to get rid of the issue of, you know, what was I going to say? In case this is accidentally incorrect, well, here's what I can do. Square root of 9 is 3. 3 is not half of 9. So this is 9 is 3. 9 is 3. Now when I run this, I can see, okay, there's an error. Something went wrong. And obviously, okay, half, not quite right. But it's possible someone could do something like this. If number modulus 2 is 1, return 3. Otherwise, return half. Again, this is definitely not correct. But if I run this, looks like everything is fine. So we probably don't have enough test cases still. Now, this, I don't want to get into the exercise of just writing like 50 million if statements for every possible situation. But probably it's a good idea to at least have maybe a few, and then we have one that's like a pretty big number. Let's say 144, the square root of that is 12. So 144, 12. And now at least we get an error for that. You don't necessarily need to have a ton of test cases for kind of similar things, but there are a few things that are worth having test cases for. One example is anytime that you're taking integers, not only should you check for positives, but you also should check for negatives and for 0. So right now, like obviously this is like not quite right at all. But maybe we can write like really quick a little function that actually will give us some square roots, or at least like kind of approximations. So for I is 0, I less than number, I plus plus, if I times I is the number, return I. So for each number up to the one that we're looking at, and in fact, we can actually cheat a little bit and even divide this by 2, because that way we're guaranteed to, actually, well, we'll leave it as num. You can kind of find ways to make this go a little faster, but we'll leave it as num for now. So for each number up to the one that we're actually looking at, if that thing squared is our number, we found the square root and we return it, right? So now when I run this, oh, I forgot to, we'll return 0, and this is our, actually we'll return -1. This is our indicator that no root was found. So if we get a -1, that means we couldn't find a root. Okay. Now I can see everything is okay. But what if I do this? Square root of -1, or let's say square root of 0. The square root of 0 is not -1. The square root of 0 is 0, because you can just multiply 0 by 0. So we have a mistake, which is again that this doesn't quite work for our special case of 0. So how can we fix that? Well, one way is to do this. If number is 0, return 0. That solves that case. But we still have another problem, right? Which is, what if the function is negative? Maybe we're okay with this. Maybe we actually say, you know what, it's fine. Ideally, you should get I, right, the imaginary number, but I think that might be beyond the scope of what we're really capable of doing in this course. So I think it's sufficient to say square root of a negative number is you're just not going to find it. But maybe some of you have noticed at this point, there's another major kind of issue with this, is that the square root function only takes integers. What if I want the square root of 2.2? I'm kind of out of luck, right? So if it's expected that this function should handle both integers and floats, you should test both of those things. Just commenting this out a little nicer. Okay. And obviously if we do square root of 0.5, it will say it can't find it, even though you perhaps could. Maybe 0.4 is something more reasonable, because 0.4, the square root of 0.4 is, not 0.4, the square root of a quarter is a half, right? A half times a half is a quarter. So this is one that reasonably it should be able to do, but clearly it can't. And we can like import math if we really wanted to. Square root of 0.25. There's my half that I want. But obviously, a lot of the functions that you find in these libraries have been vigorously tested, and that's the reason that we wouldn't really end up writing our own square root function most of the time. We would use the one that's there, and it's already built in with all these contingencies in mind. But if you're making a function, you may not have thought of all these contingencies. Things that are good to check are very big numbers. 144 isn't even really that big. You should be checking, if you're running something that has integers, does this work with like millions or billions? Is there a point at which the input is still feasible, but will cause things to mess up because the numbers are too large? Try it with 0. Try it with the very small decimal point numbers. Try it with negatives. These are all things that you should be considering when you're making test cases for functions, especially if they work with integers. This one wasn't really clear. It didn't say it was an integer or double, which is another thing to think about. Maybe it should specifically only be for integers. Maybe it should only be for doubles, or both. That sort of depends on what function is there, and that's why there isn't really one right answer to what test cases should look like for this. There's many ways that they can go, and there's really never any way to guarantee that you've actually done enough test cases, because someone could always think of some weird side scenario that's able to bypass it. Okay. Now, moving on to print statements. I find personally one of the most convenient things when a little piece of code isn't working for me to do is to just put print statements in there. figure out where is the bug based on adding some in. So there's some sample code in the folder. I'm going to duplicate that. We're going to call this edited. Yeah, edited. There we go. Okay. All right, and just as a reminder of what we're doing, put the note up here. So take this code, inject print statements to help you find the bug. Here is some code. It says flawed sort. It's probably some kind of sorting thing. Here's some other code. I don't want to understand what this does. That's so much time. What we're going to do instead is, first off, we're going to run it to see what happens. And I'm guessing that there's a mistake in here. So if this is supposed to sort stuff, oh, did it not? Oh, I probably need to see if it's sorted. Huh? There we go. Okay, well, this is clearly not in order, right? 3 comes after 1. So most of it is in order, but some of it is not. And so clearly there's a mistake somewhere in this code. But what's the mistake? It's kind of hard to see, right? So what we can do is we can inject print statements. We can say, all right, we're going to jam in some code inside of here to print out the value of things so that we can see what they are. Now, printing out an array is a bit tricky because I essentially have to print out I have to run a loop that goes through each element of the array and prints each one out one at a time. So rather than spewing a ton of code inside of here, I'm actually going to write a function. And my function up above is going to be called print array. It's not going to return anything, but it's going to take an array as a parameter. And also the size of that array. You need to know what the size is or it's going to be tough. Okay, so for I is 0, I is less than the size, I goes up. We're just going to print out the element of the array, and then maybe we'll do a little hyphen after just to make it visible. So the element with a hyphen and a space. I think that should be good. And it's array of I, and this will make sure everything in the array gets printed out. Okay. Now I can just run print array with my array and the size, and we'll see what happens. So let's say I put it here, right at the beginning of my program. Print array, array size. This is cool. It prints it out at the very beginning. But it doesn't really tell me much, right? It shows to me at least, okay, the program was able to get this array, and it got in here, and then there's some loop that does stuff, and there's some other loop that does some other stuff. So let's go actually all the way in here and jam it right in the middle and see what happens. So here's my print array at the beginning. And let's jam one right in here. See what happens. Cool. This is not particularly helpful, right? And we have a bit of an issue, which is that my print array function is just printing numbers, and I literally cannot learn anything from this information. So I need to fix this. Right now my issue is that it prints out the array, but it doesn't print out anything to separate it from the next line. So I should add a new line character to help me out with that. Okay. This is a little better. But there's so many numbers here. Like, I can't really see what's going on. It's not super clear. There's just so many duplicate numbers, and it just goes over and over. You know, it's going to take me forever to read through this. I don't have time for that. So we're not going to put this here, because that's too much printing. Maybe let's put it back a level. Let's put it up outside this while loop, but inside the other one, and see what happens. This is a little bit shorter, so now I can actually fit this on one screen, and I can kind of look at what's happening. So what's going on here? Looks like there's still a few duplicate lines, but that's okay. The first 3 are kind of the same. But then what's happening? Oh, this 4 got moved over from here. Then the 4 got over to here, and then the 4 got over to here later. The 1 looks like it got put in the right spot here, and that stays for the whole time. How about these 2s? They go here and they go here. So it looks like almost all of it's going okay, except that this 3 never gets touched. But that tells me something. If the 3's never getting touched, that means most likely whatever the mistake is to do with this first element. Something weird is happening. And wait, what's this right here? There's some variable j, which is I plus 1, and I is 1 to start. But arrays don't start at 1. Arrays start at 0. And look at that. One simple mistake. All it was some number was a 1 instead of a 0. And I could go through this with tracing and try to figure out what's there, or I could do a bunch of test cases and figure out what those test cases are doing. But in this case, actually the simplest thing to do was just print out what the array looked like at every different spot, and I saw a pattern. Everything seemed to be doing things right, except the first element was not where it was supposed to be. And if the first element's in the wrong spot, well, first element, let's see where that's handled. If I is 1, we're not even handling the first element, because everything in here references i's or j's, which are bigger than I. At no point do we hit the 0. So it just never gets touched, which is because this was incorrectly set. And that one little bug in the very first line is all that I had to repair. Okay, let's finish up with the last exercise. So in our last exercise, we're going to use a divide and conquer strategy to find out which cell has an error and then find that error. What is this code doing? Well, it's a bunch of functions that modify text. This one adds something to text. This one puts something in front of it. This one reverses it. This one makes it uppercase, lowercase, removes the spaces, multiplies it, I guess specifically duplicates it. This one mirrors it, so it's hello and then hello backwards. Then this one obscures it, and this one adds a hello to the front. That's a lot of functions, and you may just not have the time to read through all of them. Maybe they're longer than the ones that you see here. For example, you could go through, code trace or test, or even add print statements to all of them to figure out, okay, one at a time, is this function working, and so on and so forth. But that could also take a while. Look at all these functions we have to test. Rather than going one at a time through each function to figure out which one's not working, you can do what's called a divide and conquer strategy. Meaning, rather than one at a time looking at these, we can say, you know what, let's just look at half of them first. So I'm going to cut this in half, comment it out. So here's my text that starts with the word user, and it's supposed to greet, append, prepend, multiply, and obscure. Let's see what happens if I run it. Oh, I made a mistake. I should run all the cells. That would help. Okay. Not super helpful because it's all obscured. So maybe let's remove the obscure as well. Well, it greeted the user. We can see there's a hello user in there. It added some text. It appended. It prepended some text. You can see that there. And it looks like it duplicated it. So in order, the first thing was it changed user to hello user, then it appended, then it prepended, and then it duplicated the whole thing. So far, everything seems good. Okay. Let's forget that for now. If this is all correct, none of it probably has a bug, so we'll just leave it out. How about obscure text? Obscure text I feel like is probably correct because it's just adding stars in, so we can ignore that one too. Now let's look at all the other ones that are left. We're supposed to mirror the text, remove the spaces, make it uppercase, lowercase, and then reverse it. It seems to have just given us user. So something odd is happening here. Let's think about what should be going on. The text should be mirrored, so it should be user then user. All the spaces should be removed, although there weren't really any spaces to remove. Let's see if we can fix that. Maybe we'll put back in the greet user. Okay, so remove spaces probably works because it removed the space from here. Okay. Well, 2 uppercase and 2 lowercase doesn't really make sense to test both of those because whichever one happens second is the one that's actually going to happen. So let's just try one at a time. Uppercase seems to work. If I don't do either of them, it should just be normal. And then lowercase should make it lowercase. Okay. So already we've narrowed down. There are 2 of these where it clearly must not work. Let's try reverse text. looks right. User reversed is RESU. How about mirror text? This seems to have given us the same thing. Let's look at our mirror text. We get a mirrored string, we reverse it, and that's it. This looks like a mistake because we don't want just the reverse of the mirror text. We want the reverse of the mirrored text plus the original text in front of it. So it really should be the text plus the mirrored text. Can I concatenate like that? I think so. And there we go. We have solved our bug. And we didn't have to go through every single function to figure out what was there. All we had to do was divide and conquer by splitting up the functions that are there, making sure those ones worked. And once they worked, comment them out. We don't need them right now. We're just going to focus on the error itself. All right, and that's it for this topic. Definitely debugging is a skill that isn't one that you can really just be taught. It is something you have to learn. It is something that only comes with experience and practice and a lot of exposure to all kinds of different errors and bugs and mistakes that you might run into. So really, I would say that this is a topic where it is something that's going to matter a lot to you because you are going to spend most of your coding time probably debugging. But in that, I think it's helpful to at least have a few strategies that will help you out, whether it's tracing through so you're not having to run your code every time. You just kind of can figure out what small blocks of it might be doing, how to make good test cases, how to put in different values that actually make sense for what's there, putting in print statements in places that will show you what's going on, and then finally a divide and conquer strategy where it's really less about a precise method that you're following and more about the idea that rather than overwhelming yourself by having to look through every line of code, figure out what works, what doesn't work, ignore the stuff that you know is correct, and then focus on the stuff that is likely to have the problem. So hopefully this is helpful, and good luck with your midterms.